Hi, I'm Huiying Wong. My research is about extracting actionable insights for the coronary drug-eluting stent for doctors. Basically, this is a medical device that often used to treat narrow coronary arteries in patients with coronary artery disease. This device is classified as a class 3 implanted device, so any problem with it can cause a really serious impact to the patient. Therefore, I aim to help the doctors to understand the whole impact based on the previous adverse events report submitted to the FDA. Now I will be sharing what I have done so far. So basically, I have 4 objectives to where I aim to achieve. First, extract all the adverse events from the test reports for this stent. Then find out the best groupings for this adverse event with k-means. And then third, doing trend analysis year-wise based on the cluster I found to look at the bigger picture of which stent is causing more problem. So that next time before the surgery, the doctor can choose the safer one for the patient. I also aim to help the doctors to understand the adverse reactions for each report. So I will be creating the red chatbot specifically to answer every details about the reports. So now let's see how I prepare the data set. So this diagram shows how I prepare the data from FDA. Basically, I combine the device data, test reports, and master file from the FDA with the MDR report key and filter only for the coronary drug-eluting stent and get the clean data set with everything. For now, I have around 90,000 reports for 10 years, which is from 2014 to 2024. And moving on to extracting the adverse events from the test reports. Basically, I use 2 methods to find all the events as I can. That are first reading lots of the research papers to find the common adverse event for this stent. As like in this screenshot, we can see around 50 adverse event I can find from the research paper. And then I also use a well-known name entity recognition model to find all the signs and symptoms from the test reports. So with these methods, I am able to capture 291 adverse events from the test, and these are edema, asthma, and etc. So next, I aim to identify the clusters based on the adverse events found. Basically, I use the BioLot as embedding model and k-means as the clustering algorithm to group the adverse events. You might wondering, what is BioLot? So it's an embedding model that fine-tuned on large biomedical dataset and proved to have strong ability in retrieving the biomedical related content. But before that, we definitely want to know what should we put for the K, which indicates the number of clusters in k-means. So I will be using elbow method that compute a score called within cluster sum of square, which is a matrix used to evaluate the compactness of the cluster in k-means, and pick the number with the lowest score, which is 20. So my k-means will divide all the adverse events into 20 groups. But yeah, it's always important to manually evaluate the result before saying that, yeah, these are the right groupings and these are the right one. So I also look at the final groupings and regroup some of the events to make it better. Yeah, so the result is I group out 291 adverse events into 20 groups. For example, we have renal and hepatic dysfunction. Then we have liver damage like renal failure as the adverse event. Then another one is like allergic or immune reactions. And then adverse events could be rash, asthma, and etc. So we can see they are quite distinct from each other, and the model did a quite good job in this part. So moving on to trend analysis. Basically, this bar chart shows the total number of MDR reports received over 10 years for each clusters. As we can see, most of them are reported with device malfunction problem with more than 25,000 cases over 10 years, followed by occlusion, device displacement, and etc. And I also find out which brands are causing most problem over year. As we can see, the Resolute on CRS, which is the green color one, was the most frequently reported stent in 2018 and 2019. They accounting for up to 40% of all reports during those 2 years. After that, it dropped a lot, but still is on top 10 brands with most problem. So we definitely want to look into it. While for Science Guide Points drug-eluting coronary stent, it is also showing an increasing trend starting from 2022 to 2024. You see the pink color line? Yeah. So it shows the potential threats that if we use it more, yeah, there is a threat. Then moving on to this chart, it shows which manufacturers had the highest number of incidents over the year. So from 2014 to 2017, you can see the orange line. The Boston Scientific Galway showing an increasing trends in incident reports. However, from 2018 onwards, like it's not in the top 5 list anymore. But from 2018 to 2024, Metronid Island, which is the red line, emerged as the manufacturer with the most reported issues. So you can see the red line is always the highest for like with that 5 years. So therefore, the doctors should be aware of these two stents from these two manufacturers. After trend analysis, I also implement the red chatbot this trimester. So this diagram shows the overall structure of how my chatbot is working. Basically, I transform all the reports into chunks, and then using the embedding model called OMini LML6 version 2 to embed the documents and then store into the vectors database and get it ready. And this model is used to embed the user query as well. And then we will use it to find all the most relevant documents from the vector database. And then we also use the Gemini as large language model to process the user query and answer the user based on the reported form. And yeah, this is the chatbot that I have done. So basically it can be used for information retrieval, where like, let's say, we ask, what is the gender for this report 1, 2, 3, 4? And then this chatbot will search for report key 1, 2, 3, 4 from all the reports and then find each gender and answer you saying, oh, the patient with report 1, 2, 3, 4 is actually a male. And then it also can be doing trend analysis. So basically, we can see, let's say we are asking, oh, tell me the trends of reports for each gender across the year. And this chatbot will be return you the answer showing the total reports receiving every year for each gender. Like for example, male 5 reports in 2018, 7 in 2019, 409 in 2022. But we definitely want to validate its accuracy. So I will be using this framework called RAGAS, which is commonly used in evaluating the performance of red chatbot. So there's a lot of metrics, and I picked the 3 metrics that is most important for my chatbot. First is faithfulness, where we assess each query in test dataset and asking, is the answer fully supported by the context? Well, it fact one if the data is not exist in the database. And I managed to achieve 95% accuracy. And I also test how relevant the answer is to its original query, and the accuracy is around 91%. And last, I test for the correctness, which is I ask, is the answer from the bot is really based on the expected answer? And then 91% of the test cases are correct. And therefore, we can conclude this chatbot performs relatively well in handling requests related to like all the reports. And just now, I is evaluating the performance of chatbot using Raga's framework, but I do further test its accuracy by implementing the scoring system called Roche score to allow like automatically assessing the accuracy. So I picked the F1 score as the matrix, kind of balance between precision and recall rate. So the result is fairly good, which is like the average is around 55%. And yeah, so now I have finished all my research objectives. The next step could probably be further improving the current red chatbot by fine-tuning an embedding model to have better retrieval in getting the right documents. Another aim is I aim to identify the factors that significantly cause this adverse event from happening. I might implement a regression model or I will be looking into what is the right machine learning method to find out what is the significant factors that causing this adverse event. And yeah, that's all from me. And these are the reference I use in this research. And thank you for your time. Hope you like this presentation. Yeah, thank you.